Good morning, viewers. I've come today with a new chapter and a new subject, that is physics today. Okay, so physics, I'll be starting today with the first chapter of physics, measurements and experimentation. Okay, this is according to ICSE syllabus, class 9. Okay, so I have started chemistry chapter 1 and biology also chapter 1 for class 9 syllabus. So this is the physics chapter I'm starting today. Okay, so for to in the beginning I will say you that please go through these videos, the text videos first and then to the question answers. Okay, and that will help you in your studies. Okay, much more you will understand the chapter and then you go to the question answers that will help you in solving them you on your own. Okay, so you have to stay tuned with me. You have to subscribe my channel to get the notification of my next videos. And also, if you are liking it, then press the like button and also share with your friends so that they can also be benefited from these videos. Okay. And one more thing I told you earlier also that before sitting on studying, I mean, if you when you are sitting for studying the lesson, starting your studies for the day, meditate for some time, so at least 2 minutes, think of a dot, white dot. If there is nothing to think about, you put a dot, white dot on the wall and meditate on that, concentrate on that, as if some energy is uh, getting inside from that white dot. Okay, and that will create your that will enhance your energy, enhance your mental capacity so that you can retain the whole studies which you have learned, which you will be learning the whole day. That will be that retaining capacity will increase and also recapitulate what you have learned the whole day. Okay, so these things will uh, increase your concentration power. Okay, that will help you in your studies. So let me start with the lesson today. Okay, so first is the systems of unit. Okay, so physics, like other branches of science, that requires experimental studies that needs measurements. Okay, so physics, it's also a branch of science. It's all other branches of science like chemistry, biology, like this. So it is also a branch of science that requires experimental studies, which needs measurements. Okay, now what is measurement? Measurement is the process of comparison of given physical quantity with the known standard quantity of the same nature. Okay, one physical quantity is given and you are comparing that physical quantity, that given physical quantity with a known standard quantity of the same nature. Then the standard quantity is used to measure and express the given physical quantity is known as the unit. So what is unit? Unit is the standard quantity which is used to measure and express the given physical quantity. The given physical quantity is there. Uh, Comparing with the standard quantity, that is measurement, and expressing that physical quantity while measuring it is the standard quantity that is used to that measurement, for the measurement and expressing the given physical quantity, that is known as unit. Therefore, what it is the quantity of a constant magnitude that is used to measure the magnitudes of the other quantities of the same nature. So what is standard quantity? Therefore, the standard quantity is a quantity that is constant. Okay, that is constant magnitude, that does not change. Okay, that is used to measure the magnitudes of other quantities of the same nature. Same nature is there, only they are of different quantities. Okay, so if we're measuring their magnitudes, a constant magnitude is used and that is known as standard quantity. Okay. The result that is obtained after measuring a physical quantity is expressed in terms of the following two parameters. The standard quantity in which the given quantity is measured is called the unit. Okay, how in which the what is the result of that is obtained while measuring the physical quantity? Terms, two parameters are there. One is unit, another is the numerical value. Okay, so the unit, I told you, it's the standard quantity in which the given quantity is measured. That is the unit, and the value that expresses how many times the above selected unit is contained in the given quantity. How many times the selected unit, the given quantity is there, that is known as the numerical value. So physical quantity is equal to numerical value into unit. Okay, next is some examples are there. See, the length of a piece of cloth, that is 10 meters. Okay, what does it mean? It means that the length is measured in unit meter. Okay, its unit is meter. The length of the substance of the piece of cloth, that's unit, the unit of this length is meter, and this unit is contained how many times? 10 times in the length of the given piece of cloth. Okay, that's why it's termed as 10 meters. Again, the mass of a given quantity of sugar is 5 kilogram. That means what? That means that the mass of the sugar is maintained in the unit. What is the unit for measuring the mass of the sugar? That is kilogram. Okay, and the unit is there in 5 times the given quantity of the sugar. 5 times. That is why it is known as, it is given here, it's 5 kilogram. Kilogram is the unit and 5 is the numerical value. Okay, next is how to choose a unit. As a unit has to be used universally. Okay, has the unit is to be used, has to be used universally. That is, it should be universally accepted. So it should be valid every time, everywhere. Okay, therefore, the chosen unit should have some following properties. So what are the properties the chosen unit should have? First is they should be of convenient size. That is, they should be universally accepted at all times. Okay. Next is there should be possible to define the unit without any ambiguity. That is, without any doubt, it should be defined. Then is should be reproducible. The standard unit can be used repetitively to retain the consistency of the units independent of space and time. The stand should be reproducible. That is, it can be repeatedly used to retain the consistency of the units independent of space and time. The value should not change with space or time. Value should not change with the space of time. If we go to some other place or the time increases, then the value should not change. It should remain the same everywhere. Okay. Next is the kinds of units. One is fundamental or basic units. Another is derived units. Okay. So fundamental units is a unit which is independent of any other unit, or which can neither be changed nor be related to any other fundamental units like length, mass, time. They're independent of any other unit. Length is not related to mass, neither mass is related to time. So they are independent to each other, and they can neither be changed nor be related to any other fundamental units. Then derived units are those units which depend on other units, other fundamental units, or which can be expressed in terms of the fundamental units, like say volume or area. That can be expressed in terms of length. The like volume is named as L cube or L into B into H. That means all these things, L, B, H, these are the lengths. Okay, these are the lengths, or L cube you can say. So volume can be expressed in terms of length. Then area also, area is equal to L square or L into B. So these are all the lengths. So area can be expressed in terms of some other, and length is a fundamental unit. Okay, so these can be expressed in terms of length. Then speed is equal to mass, distance by into time. Distance by time. Then distance is measured in length. A distance is the length, and time is the separate fundamental unit. So length is also a fundamental unit. Time is also a fundamental unit. So speed is a derived unit. Next is systems of unit. See, there are 4 systems which are followed, systems of unit which are followed in the world, to whole world. First, CGS or French system. Here, the length is measured in centimeters. Okay, then mass is measured in grams and time is measured in seconds. Then FPS or British system. Here, the length is measured in foot. Mass is measured in pound, LB that is. Time is measured in second. Then MK system or the metric system. Here, the length is measured in meters, mass in kilogram, time in seconds. SI or system internationally units. Okay, this here the length is measured in meter, mass in kilogram, time in seconds. So see, these are the 4 types of systems which are followed for measuring throughout the world rather. Okay, so see, these are the examples of the fundamental units. Some other fundamental units are also there where these units are different in different systems. These units are, yes, these units are different in different systems. So generally now this SI system is followed. Okay. Now see the physical quantity. Okay. See the physical quantities. These are the fundamental units: length, mass, time, electric current, temperature, luminous intensity, amount of substance. And the units is meter, kilogram, seconds, ampere for electric current, temperature, Kelvin, K, luminous intensity, candela or CD, amount of substance is mole, or mole is a symbol, MOL. Then supplementary quantities: plane angle is radian, RAD, solid angle steradian or SR. Okay. Next is some prefixes which are used with the units. Okay. Like 10 to the power 1 is known as deca. You can write the symbol as DA. 10 to the power 2, hecto, that is H. 10 to the power 3, that's kilo or K. 10 to the power 6, mega or capital M. 10 to the power 9, giga or G, capital G. 10 to the power 12, tera or capital T. 10 to the power 15, peta, capital P. 10 to the power 18, exa, capital E. 10 to the power 21, zeta or Z. 10 to the power 24, iota, Y. Then some other factors: 10 to the power -1 deci, 10 to the power -2 centi, 10 to the power -3 milli, 10 to the power -6 micro, 10 to the power -9 nano, 10 to the power -12 pico, 10 to the power -15 femto, 10 to the power -18 atto, 10 to the power -21 zepto, and 10 to the power -24 yocto. The symbols are small d, c, m, small m, then small, this is mu. This is N for nano, then pico, P, small p, femto, small f, atto, small a, zepto, z, and yocto, y. Okay. Next is units of length. Now, SI system of the unit of the length is meters. We write it as small m. The original definition in 1889 was a meter is the distance between 2 marks drawn on a platinum iridium rod. Okay, what is that rod? It's an alloy with 90% of platinum and 10% of iridium. Okay, that is known as a platinum iridium rod, which is kept at 0 degrees centigrade in the International Bureau of Weights and Measures at Sèvres near Paris. Okay, there's a International Bureau of Weights and Measures at Sèvres near Paris. There, this rod is kept, and the distance between the 2 marks which are drawn on this rod is measured, and that is known as meter. It is the original definition which was made in 1889. This temperature, this measurement was done at 0 degrees centigrade. Now, Later, this definition was modified into 1960. In the year 1960, it is said that it is 16 lakhs 50,000 or 1,650,000. Yes, 650,763.73 times the wavelength of a specified orange-red spectral line, okay, in the emission spectrum of krypton 86. Okay, in the emission spectrum of krypton 86, this when this krypton 86 was this orange lead light emitted from this krypton 86. It's a radioactive metal, krypton 86, from when an orange lead spectral line that emitted from the krypton 86, the length or the wavelength of the specified line was 1,650,763.73 times this wavelength, and that is known as what? The meter. Then again, it was again defined as 1,553.164, 1 million, this is 1,553,164.1, okay, times the wavelength of a red line in the emission of cadmium. Again, cadmium is a radioactive metal, and if a red line is emitted from this cadmium, it is made to emit a red line. The wavelength of this red line is how many times? 1,553,164.1 times. Okay, that is known as meter. Then again, in 1983, it is said that it is the distance traveled by light in 1 by 2,299,792,458 of the second in air or vacuum. Okay, so in this limit time, lots of fractions of seconds, okay, 1 by 299,792,458. Okay, so it's very delicate, I can say. So that distance traveled by light in this particular time is known as the meter. Now, the subunits of meter is centimeter, millimeter, micron, and nanometer. The definition of centimeter is 1 centimeter is 100 part of a meter. That is 1 centimeter is equal to 1 by 100 meters, or you can say 10 to the power minus 2 meters. The definition of millimeter is 1 millimeter is 1,000 part of a meter. That is 1 mm is equal to 1 by 1,000 meters, or you can say 10 to the power minus 3 meters, or you can say 1 by 10 centimeters. Okay. Now the units of length, again, it's a continuing. I'm continuing that only. So definition of micrometers, or you can say micron, it is 1 millionth. Okay, 1 millionth part of a this one meter. One is 1 micron. Or you can say 1 micron is equal to 10 to the power minus 6 meters, or you can say 10 to the power minus 4 centimeter, or you can say 10 to the power minus 3 millimeters. Now, nanometer definition is, it is the 1 billionth part of the meter. Okay, that is, you can say 1 mm is equal to 10 to the power minus 9 meters. Now, there are certain multiple units of meter are kilometers, larger than meter. That is kilometer. So some non-metric units length are bigger units and some are smaller units. Now bigger units are astronomical units, light year and parsec. An astronomical unit, what is that? It is equal to the mean distance between the Earth to the mean distance between the Earth and the Sun. Okay. So it is, I'm sorry. It is equal to the mean distance between the Earth and the Sun. Mean distance of the Earth and the Sun is the astronomical unit. 1 AU is equal to 1.496 into 10 to the power 11 meters. Okay, 10 to the power 11 meters. Now, again, we are coming to light years now. It is the distance traveled by light in vacuum in 1 year. 1 year is equal to speed of light into time 1 year, that is. So speed of light is 3 into 10 to the power 8 meters per second into 1 year means 365 days into 24 hours and 60 into 60 seconds. So that will come to 9.46 into 10 to the power 15 meters, or you can say 9.46 into 10 to the power 12 kilometers. The distance of stars from the Earth is measured in the light years. Okay, the smaller units are light minutes and light seconds for light year. Light year, the smaller units are light minutes and light seconds. So light minute, 1 light minute is equal to 3 into 10 to the power 8 meters per second into 60 seconds. That is equal to 1 into 1.8 into 10 to the power 10 meters. And 1 light second is 3 into 10 to the power 8 meter per second into 1 second. That is 3 into 10 to the power 8 meter per meters. Okay. Now, parsec, it is the distance from where the semi-major axis of the Earth, that is 1 AU, subtends an angle of 1 second. Okay, 1 parsec into 1 minute. That means that gives us what? 1 second. 1 AU, sorry, 1 AU. Okay, it's not 1 minute, it's 1 second. Angle in 1 second. So 1 parsec, you can say arc length by angle in radians. So arc length is 1.496 into 10 to the power meters, 11 meters by 3600 into pi by 180. Okay, that is angle in radians. Now 3.08 into 10 to the power 16 by 9.46 into 10 to the power 15 light years, or you can say 3.26 light years. Now the smaller units are angstrom and Fermi. Angstrom, what is angstrom? It is 1/10, it is 10 to the power minus 10th part of a meter, expressed in a to the power 0. It was used to express the wavelength of light, size and separation between two molecules or atoms, radius of orbit or electrons, etc. 1 angstrom is equal to 10 to the power minus 10 meters is equal to 10 to the power a minus 8 centimeter to the power minus 1 nanometers. 1 micron is equal to 10,000 angstrom and 1 nanometer is equal to 10 angstrom. Nowadays, angstrom is replaced by nanometers. Okay. So, and for me, it is 10 to the power minus 15th part of a meter. Therefore, 1 Fermi is equal to 10 to the power minus 15 meters. Okay. So I think I'll stop here. I'll continue with the rest of the chapter in my next video. So please go through this. Again, I'll request you to first go through this text portions, text videos first very carefully so that you can, by own, you can solve these your question answers, the back questions of the chapter, as also some other practice questions, which I will also discuss with you, some ICSE patterns questions. And for all these things, you have to stay with me. Do subscribe my channel. Do press the like button so that I can also be motivated to produce you some good videos and some videos with new ideas, so that can help you in your studies much more. Okay. So thank you for watching and have a good day.